Hey, good morning, everyone. So welcome to another stream today, and I think in the theme of this current 2 weeks, we're going to be how do I say this? We are going to be improving this custom little BLE service that we are developing on this little dev board, which is NRF 52840. It's just basically it's an SoC with a radio on board, and we are really interested in using the radio properly. Okay, cool. I plugged it in. Let's see what it shows. I've plugged it in. If I go to my local Bluetooth scanner app, you know what? Scan BLE on Ubuntu. I wasn't ready to do that. Do I have HCI tools? Really? Because then HCI tool. Oh yeah. At least gone. Oh. HCI to LE scan. Ooh, how to use it? HCI tool, how do you use it? Options, commands. HCI tool -I scan. No such device. How do you use it? Anyways, let's not add something new and make the stream about learning a new topic. But basically, if we go into my Bluetooth scanner app, I'll avoid opening both of them at the same time so that we can use each one of them. So if we go into my Bluetooth scanner app, we should see temp and light application. Yeah, it's the first one. Cool. And then on the temp and light application, we can connect, and it's an environmental sensing service. And then in there we can see an environmental temperature sensing service. And if we press read, you can see some hex values over there. And the reason we're seeing hex values is because we have not done the format conversion, so that it's just sending raw bytes over to the phone, basically. And what we want to do is we would like to set it up so that, number one, it uses multi-threading. Let's look at the repo. I did some work yesterday, so I'm going to go back. Yeah, here. Let's look at it here. Can we browse files? Let's browse files. So let's browse files. This was how the application looked yesterday. And then what we had a main module, and this main module did everything. So inside our main module, we had some global state, which we already have, and especially this is the reason we're going to be doing most of the work we're doing today is, number one, to get rid of global state, and to try and make it so that we can read through stuff easily. First of all, we have almost 150 lines in here, which is not bad. It's a very small module. Modules can be really much bigger than that. But then you don't want your entry module to be as busy as this. Or rather, I don't want my entry module to be as busy as this. So in here, let's quickly review what we did. We registered the module for logging, and then we made some globals to do some stuff. We have a BLE ready, we have a temperature value, we have a temperature float, and then we have a callback function that we use whenever I press the read button over here. Wherever I press the read button over here, so this is going to be the read button. Next time I'll have made it work with the computer so that we can just see it on the screen. Whenever I press the LE button over there, read button, this callback is engaged, and then this callback will return the value, and that's the other thing. And then we have we want to define our advertising packets. So what an advertising packet is, just as a recap, is what the radio on the small device is pinging. It's just saying, this is who I am, this is who I am. If you know me, you can connect to this. If you know me, you can connect to this. And then some of them have an option of just connecting to them. Okay, cool. And then after that, we defined a general attribute service. Okay, so we have a gap general. We have a gap profile, which is a general profile, and then we have a general attribute service. And then so this service is basically, when you go into the application, it says environmental sensing. So that's the primary service. And if you look carefully, you will see that on the environmental sensing section, there is a small hex ID, and the same hex ID we are seeing on the application is the same hex ID that we are seeing in the code that is in front of us. And then along as that, we also define, for this service, to define a temperature characteristic, which is also, you can see an ID there that matches on screen and on the camera. Sorry about that. I don't know, maybe I can, no, I'm not going to do that right now. So we define a service, and then after we define our service, we define a callback. Read custom characteristic. We actually implement the callback, because this is going to be needed inside this is going to be needed in the main function. So we implement the callback. Okay, cool. And then we have a function that we define that's going to check whether Bluetooth is ready or not. And then we also have a sensor function. This is a function that the main function is going to use when reading from a sensor. This is a part of the sensor API. Zephyr sensor API. That's a part of the Zephyr sensor API, and it's basically this part of it. I think there's a definition somewhere here about consuming. Just one moment. I should get it just now. So you see, we can, this is just, that function does this, sample fetch. It just does this instead of doing it inside our while loop. We just constructed a little helper function that does it outside of it. Okay, so that's what we did yesterday. And then now you finally get to our application. Do you see what the problem is? Number one, I think this almost starts to show what problem we are encountering, because you have to go through 100 lines of some code before you get to actually what our application is doing. And then in here you realize our application initializes BLE, and then once BLE is ready, it will start advertising. And then once Bluetooth is set up, it will initialize a sensor, and then once the sensor is set up, it will now start fetching the temperature value and setting the temperature value. Once you fetch this temperature value, you're probably going to, how are we, yeah, so we fetch this temperature value, okay, we fetch it and we put it in a float, in a temperature float. We put it in this float and then it just stays there. Okay, we keep fetching it and putting it there, and then whenever someone triggers a read from the central device, then we run this function, which gets the user data. Okay, remember we set here our temperature float as our, we set this function here to run here. Okay, cool. In our characteristic, when you read this function, we set it so that you can use that function when you read, and then we set this value, the temperature float, as a value that you would be reading. Sorry, my mouse is dead. Okay, cool. So let's move here. I've had a cold for so long now. Okay, cool. So once we've done that, our callback already uses that value. Okay, so we have a global value that our callback is just using, and then our callback waits for it to be called and it would use it like that. Cool. So that's how our application looked yesterday, and that was really bugging me. So what did I go do? What I went and did was I did this, and I want to see. Yeah, so these are the changes. No. This is just documenting them. I want to see all the commits. How many commits are in here? How many commits? 5 change. One file change. This is wrong. Did I squash something? Okay, wait. So when did I do that change? I have not done that change. I have done that change. Oh yeah, so this is the one I want to see. Cool. Now, let's look at what happened here. So 5 files, we added 5 files. And what we basically added is we broke out the BLE work into its own file, as you can see. So what now we have is BLE happening in its own file. I'm just using the UIs so that I can show the changes with diff, and then we can go back to writing code on our machine. So we added a BLE service, and that took away all the BLE setup into its own implementation. Cool. Yeah. Just doing the same thing, doing the exact same thing that we were doing in main, we're doing it in BLE service. Okay, and then of course we added a BLE header so that we can access those things from other places, mainly main and such. And then in temperature, we added a temperature service that just does the same stuff. Goes and fetches a temperature value and puts it in a certain place and all of that and such and such. And then obviously we added a temperature.h so that we can access this from main. And now what happens is, I don't want to look at the diff now because the diff will become confusing just now. And now basically what is happening is, if we go into our current main, this is what we're going to see. Let's look at how it looks. So in here, no man, sorry. This is what happens when the mouse dies. In here, we will register the log module. We still have a global state. That's a problem. And we're still doing stuff here, but we will initialize Bluetooth. Wow. and then we will do setup that is setup that we will set up the sensor. So we'll basically initialize the sensor, and then once the sensor is done, we'll just now updating every 2000 milliseconds, and then we will just start the work. Okay, so this is kind of okay. It works. I mean, it really does work. But the issue now is that we basically still have a global variable that is controlled inside. That is controlled inside of main, and that's not really where we want to be, because first of all, the global is once you're using a global, there's some probably you've kind of run around some design stuff that you shouldn't, and that's a signal, okay? And then now that means you have to deal with things in too many places. And then as well, we have in Zephyr we have primitives. Sorry, this is really bugging me. Yeah, just give me my mouse, please. So in Zephyr we have kernel objects, so kernel primitives that we can, but you can use it basically not even in Zephyr, in all RTOSes, or mostly in all operating systems. You're going to have threads, and these threads are going to enable you to do stuff like doing work in the background, doing work that takes long, doing work that you won't do immediately. This is all going to be in today's write-up, which is here. So, there's a write-up here that basically describes all this multi-threading primitives that we have in Zephyr. And by the way, if you don't want to use multi-threading, Zephyr does have an option that allows you to not use it by config multi-threading no. So you can set multi-threading to no, and basically you go back to a super loop, and you can use Zephyr. You can use Zephyr as a super loop. So everyone who, which means you can also make it quite small, and quite minimal. So basically, we have threads which have stack for read a stack thread. Yeah, a stack for the thread memory. A stack for the thread memory. Well, actually, we don't even need it. Each thread has a stack for memory, and this stack can be side for the thread itself. It has a control block for metadata, just to know what is being called or not. It has an entry point. It has a priority. It has it has a priority, and it has some options for the kernel to decide. And it has a start delay. It can be started immediately, or it can be started after a certain amount of time, or so on and so forth. I think the easier way that I'm finding to kind of explore these things is to just do I have a mouse back? Oh, so today we become kernel experts. The easier way I would find is for us to just jump down to where the work that I have planned for today. Sorry. DJ. Yeah, cool. So let's yeah. So let's think about the application that we have already right now. So we have an application right now that fetches data from a sensor, and then once it collects that data from the sensor, it basically puts the data in some global state somewhere, and then now it has a networking call that can read the state. So what can we do? We can probably arrange this work so that it can be consumed by the networking call. And we have a couple of primitives that in Zephyr that will help us. And I think it's going to be much easier if we just go around and so here I've given myself 30 minutes to do this because I usually get carried along. We're already 20 minutes in, so let's see. So let's think about it. What would be the thread architecture for this application of ours? We basically would have two threads, isn't it? We have a sensor thread that does sensor work, which is go and read sensor data and put it somewhere. Just hold that. And then we have a BLE thread that gets networking data from outside. It gets a network prompt from outside, and it's told, read from somewhere this data. Read a temperature from somewhere and give it back to me. Okay, right now this somewhere is a global thing in our application. And what we want to do is, we don't really have to make a global thing in our application. We can separate this. We can break it apart so that it works separately. If you think about it, we can have a long running thread that goes, we already know how many times we want to do this. We want to do this every 2000 milliseconds. We want to go and read the temperature. Okay, and then as for the network, we can basically provide the data as and when the person reads it. Okay, later we can add another feature where if the data changes to a certain threshold of value, we can alert someone, which is a notify. But let's not add that right now. Let's just keep the network just easy, that it just comes in and reads whenever it's triggered. So I think we'll, as detailed here in my notes, we will create a sensor thread, and then we will create a BLE thread, and then now that global sitting value that is just sitting somewhere, now that becomes a thing. And for this, I think Zephyr offers something. I think it's something like let's say 60K. Zephyr offers something called work queues, and work queues. Yeah. A work queue is a kernel object that uses a dedicated object to process a dedicated. Work queue threads. No. I want to see work queue threads. A work queue is a kernel object that uses a dedicated thread to process work items in a fast in, fast out manner. So this is wrong. A dedicated thread to process work in a fast in, fast out manner. So what does this mean? Zephyr already gives us a primitive, which is a concept that exists everywhere in Zephyr, of a work queue. And the work queue can hold a number of items, and then depending on the number of items, we want to process, it can enable us to process the items as in fast out, fast in, fast out. Okay, so we can put work in. We can. Oh, I'm done. I am done. I have gone and I have read the temperature. We've done what we are waiting for someone else to come and use it. Put it in a work queue. Oh, I now need to read the latest temperature. Go to the work queue, read the latest one. So that is the work queue that is going to do that for us. So I think without further ado, let's jump into some code so that we can make this actually work out. So I was thinking the easiest way is to add an app.h, which is just a common common for the whole app. So we can use this. It's almost like a global, but it's not really. It's primitives that we define so that we can use them everywhere else. So let's first of all make a work queue will have a list of work items, okay, a thread that processes the work items in the queue. Okay, so we need to make a list of work items and a thread that will process the work items in the queue. So here let's make first of all we need a work item. So let's make a struct temp current message. Let's do that, and then this has a float in it, float value, and then let's close that, and then okay, I want to go here. Okay, can I how do I scroll here? How do I create work queues? Yeah, so so you see, let's look at creating a work queue. Yeah, my work queue, blah blah blah. This is not creating a work queue itself, but this work queue needs something it can work on. Let's see. This is something I've seen about a work item. Okay, yeah, so look, this is a work item, and then we can call Kate submit into this device, my device.work and my device.work. But I don't see, this looks like a delayable item. I just want a normal work queue. I just want a normal work item. How do I do that? How to use work queues. So we define a work queue, and then later we'll define an item. And so okay, cool. My work queue. So we define it like this. We give it a stack area. We make a work queue like that. We initialize it like that. Oh, so I started with the wrong side. So I started by making the thing, the struct that I needed. So because that's how I understood things. Okay, cool. So in here we want to do, what does that say? Let's define our queue size. Define queue size, temp queue size. For now, I'll put 2 items in the temperature. No, there's no here. There's no that. And then temp. Let's define a size of temp. Define message temp message size. I'd like to do that, and then here we'll go size off, and then here we'll do current temp. This is not good. I do not have autocomplete, so I don't know if things are working. And then in here we have a size. So let's go back. we have a size. We have a size of the work item. We have the work item itself. Now we need to go and create. We need to create the message queue. So I'm actually going to use a message queue. I would think. Let's look for message queues. Okay, message queue. I saw that one. Yeah. A message queue is a kernel object that implements a simple queue allowing threads and SRs to, so let's go defining a message queue. It has an item. Perfect. It has that. It has that. Okay, cool. So let's k message queue init, my message queue buffer, size of struct item, and then size that. So let's use, we're using not exactly what queue, but it basically is okay, message queue define. What do we, is it because I need to do include Zephyr kernel h perhaps? Okay, message queue define, and then message queue define has a what does it take? And my message queue. Wait. Where are we going to define this message queue? We're going to define this message queue in main probably. So we're going to define the message queue in main. So temp message queue, and then we'll come back to here later because and then the buffer is going to be, this will also come from main. This will also come from main, because remember we have to initialize the queue, whenever we're starting the application, we'll just start this queue and leave it sitting by itself, and then once things are ready for it, they will come to it. Okay, so this can say temp, okay, and then this can say temp message, and then this can say temp queue size, and then this can be 5. So okay, message queue init. What do you take again? Just so we're good. So it takes the address of a message queue, the pointer to ring buffer that holds the queued items. So the pointer to the ring buffer that will hold the queued items, and then it takes a size of the message size, and then it takes the max amount of allowed messages. So I don't want more than 2 allowed messages. Let's start there. Okay. Make a message queue common to the whole app. Okay, So we've made a message queue that it's in app.h, so we can bring this header into everywhere. Okay. So now let's go into BLE. Let's go into the temp. Let us start filling things into. Let us start filling things into the what do we say? Let us start filling things. We've made a queue. We made a queue that is waiting for temperatures. So let's start putting temperatures in the queue. Okay. And then I think what we would need to do is we probably need to define a thread. That's what the notes say we need to do. Yeah. So let's go. Yeah. So we have a queue to hold the temperature messages. Now we need to make a sensor thread that reads temperatures every 2 seconds. Let's go make a thread that reads temperatures every 2 seconds. So here, let's define define a thread to read temps every 2s. So now we go back again. Let's go back and look at some code on how to do this. How do we make a thread? Okay, thread define. Okay, thread define. So probably a thread takes what? It takes the name of the thread, the stack size in bytes, the thread entry function. What is the thread entry function? Oh, no, I did not want to do that. Sorry. Zephyr threads. What is the thread entry function? I've forgotten. It is a function that will run when the thread is started, isn't it? An entry point function, which is invoked when the thread is started. Okay, it takes a function to run when the thread is started. First entry point, second entry point, third entry point parameter, priority. It takes a priority, it takes options, it takes a delay. So probably need to define something like something that returns a thread, probably, because we're going to need to orchestrate this thread from main. Void either returns a thread or takes in a pointer to a thread, and then we can probably, I want temp sensor thread. So probably we don't want to pass in a thread. What we would like to do most likely is to something like get an address of a thread and then fill this thread every 2 seconds. Yeah, is that how it works? We want to probably wait. It takes a pointer, so it's three args. Arg 1 void, so it's voids because they could be anything. Arg 2 void, arg 3. And then in here what we want to do is while let's run a thread. Let's run a thing in here that does what? In here, in this thread, we want to read the sample. Read the sample every struct. What did we call it? Struct sensor value. This is a message. This is the row message that we're getting. Row message. And then after we, this is going to be the row message that we would use, and then struct temp message. It's a current message car message. Okay, cool. And then in here we need to do a call to sensor sample fetch. Sensor sample fetch. Now this becomes an issue. I don't know. This is something I've defined here. This is fetch temp. So we need to call fetch temp. Wait. Isn't it the same thing I'm doing here? Isn't it the same thing I'm doing there? Isn't it the same thing I'm doing there? That's the same thing I'm doing. So this might end up disappearing. Why? And in here I want to do how do I get it so that I'm a little confused. Let's look at the thread again. How do threads work? So this is initializing the thread. Oh, okay, yeah, producer. So data item, yeah, that is the data item type, while one. I already have this function that reads the temperature. You see, I already have this function down here. Define a temperature, a routine to collect the temperature. So we want to create a data item, send that item to consumers. Well, I can't just say this has a float value and that returns a float. That has a float value and this returns a float and that has a float value. And let's see. Do we want it in while? Do we not want it in while? Anyways, that's just not for now. We can always Where am I stuck? I'm stuck in making the double into a message. We have, this is a raw message. This is a sensor value that we get from, this is a sensor value that we need to convert into our, we don't need to go through this because we have that subroutine below that collects actually. So what we need to do is, rather than okay, let's just go here. X. Let's put you below this one so that you already come in with a defined thing. And then in here, let's just close this syntax, and then here, and then so in here, what I want to do, I have that current message, which is a struct that's holding a float. So what I want to do is to do float temp, float car temp equals double fetch a float. So float, let's floatinize this fetch temp, but this needs to take a sensor device, and that's where I'm confused. Where are we going to get a sensor device from? Where do we get a sensor device? Def. It'll come from somewhere. Let's make the code, and then once it breaks, it's going to come from her. So that's now our float. So we fetch the thing. We fetch the thing. We have a float from fetching the thing. But where are we getting the device? That's a problem. Number one, that's a problem. We don't know where we're getting the device. Number two, we now have the float. And then once we've converted that to float and we have the current temperature message, we need to do current dot dot, you should have a dot, you should have a thing. It should be dot something like value equals car temp. Is that it? Is that really it? Yeah. What now? What do you mean it's incomplete? move that mouse. Oh, what do you mean it's incomplete? It is complete. It has a value there. And then all I do is I create it. All I do is I create it. And then what do you mean it's not complete? Anyways, and this is, yeah, I wonder if we just want to take the, anyways, let's just put all our code there first, and then once, yeah, we have that now. Let's push the work into the queue that we made before. Made a queue before, yeah. We have a current message now that we can put in the queue, that we have a current message that we can put in the queue that oh wow, tab works. Okay, we have a current message that we can put in the queue. We've constructed a message that can go in the queue that we needed, that we need to so we need to remember, we're making that, we're trying to get rid of that. We are trying to get rid of that global. So we're making a queue. So now we have an item. We have a current item. We can now push it into the if k message queue. Message. Okay. Okay, message queue. Okay, message queue put. What I want to do is to check if it's not 0. So I want to check if that is not queue, is not 0. So if that is not 0, that means it's not full. Okay. So message queue put, and then here message queue put takes a message queue, the data, and a timeout. Okay, so the message queue that we've defined before is and car temp we made that, and then it takes a what? It takes a data. So yeah, we'll take a car, what is it, and a car message, and then it takes a timeline, timeout, no wait. Okay, no wait means just do it immediately. Okay, but remember, this is still, this is actually just the condition we want to check. Check if the thing is not full. So if it's not full, wow. So I'm so concerned about that. If the thing, let's check. If it's not 0, this means it's full. Okay. Queue is full here. So drop the oldest. Remember, just I will show you where this comes from right now. So k message q page, if I remember correctly. Okay, message q page and car temp message. And temp. Okay, remove one, drop the oldest, and then still k message q put and temp q and car message and k no wait. We should be done. We should be done, if that makes any sense. I don't know why it is formatting like this. I like it like that. Why do you not like that? Okay, cool. So now that's good. So what is happening here? We're checking if we get a current temperature. We check whether the current temperature is valid. I mean, we don't even check it. We get a current temperature. We try and squash it into the queue. If there is space in the queue, we'll put it in. If there is no space in the queue, we will remove the oldest item and then we'll go back again. And then we will okay, sleep. Is it like that? Okay, second. Okay, seconds. 2. And then that's it. Wait 2 seconds and run again. Okay, we still need to deal with that missing device, but we're gonna get there just now. I think this is fine. And why? Okay. So that's fine. We made a sensor thread. This is all going to need to, we need to do all 3 things and then join them up and see if they will work together. So basically, and then this is a problem here. Wait, so this is for that one. And that. And is that why that was why. Okay, cool. So let's now go and let's just do the same thing for Bluetooth, or rather let's try and see if we can in main Now let's do the same thing for Bluetooth. Yeah, so let's do this thing where we end up writing let's write a thread for Bluetooth that uses this same queue. Okay, it uses this same queue, and what it will do is it will pull the latest value out of it will pull and read the latest value out of this queue. So once we have, let's make no, we don't need a new file, we just need to go to the BLE service, and then at the bottom we need to implement BLE threads. So let's start with the read current temp thread. And this is actually good practice, because remember, all of this is basically research for an LE audio application. And the thing about LE audio applications is they use the LE audio applications use a combination of three Bluetooth services with multiple characteristics in each service, that some of these services have isochronous characteristics, and isochronous characteristics means that these characteristics are time synced. So we're going to have a number of threads, a number of networking threads that are synced to certain time signals, and then we basically use them. So networking will, maybe I'm doing this in a naive way, and once I learn a few things it will become different, but the thing is, networking might end up, or usually will end up, having very many threads. Anyways, void BLE temp read thread, and then this will take 3 arguments: void arg1, void arg2, void I just had an epiphany. I really did. I just had an epiphany. I really did. You know, here where we were confused about the device, here's the thing. Our thing here I see now. You see, this returns a device. This returns a device. So this is amazing. So this device is the one that we need to use here. But we currently don't have that device because we keep giving it back to, we give it back to main here. We give the device back to main here. So what we're going to do is we're probably going to move this device there. Move this device there. Is there a device here named the temperature sensor? We will move this device there, and we will completely move this there, and then when we completely move that there and never bring it back this way, we will hand it over to that. We'll hand it over to that function in temperature sensing. Okay, I'm so happy that became clear. So let's now implement our, sometimes you just have to follow through and see sometimes you just have to write the broken code. Just put the broken code down, remove this from your head, put it down, and then once it's there, it's easy. So let's now go back and include app.h so that we can have it. And then here we want to do, so in here we also want struct message, struct car temp. Yeah, we want a car temp message, temp. Car temp, and then here while one we need this, and then we'll close that one out, we'll close you out, and then let's now deal with our this is our entry function. Okay, so wait, what do we do here? Wait for message from queue. Why are we waiting for the message from the queue? Why are we waiting? Why are we not performing? Okay, but let me see. If k message, so I'm just following this part now. BLE thread consumes queue, updates characteristics, and optionally sends notification. This is a feature by itself. So let's in the BLE service. So if message queue, if message queue get, so read from car temp message queue, temp, read from temp message queue, that's passing an address, and then what does this function do? Get message queue data and forever. That message queue and the data is and car temp, and then we want k wait k forever. Keep waiting keep trying to read until something. Try to read the queue until it has something. Okay, and this is gonna get me cool. So we try and read the queue until the queue has something in it. So temp float. Wait, why is this car temp? Okay, car temp. Wait. Why do you assume that there's a temp float? Why would we? So we need I see what's happening. Float equals to message car y dot value. So what have we done here? We've just updated the all we have done here. So I see what is happening here. All we have done here is we have just updated we have not gotten rid of our we have not gotten rid of this temp float. I expect I will have to do include but at some point I'll just get rid of that. Actually I'm already getting rid of that, but let's just go slowly. So first of all, let's fix this thing so that sensor temp just runs this, and then it won't return this. Let's take this code back to sensor temp. Go back here, and we need to go back to the init device construct. Okay, so we need in here we need a construct device. Yeah, I concur. Let's remove you. Let's see if there's any messages on chat. Let's do that. I want to do that. Current temperature sensor. I don't want a pointer. This doesn't need, this is just a void. You can, of course, error out. It's fine. I know what is happening here, and then this is going to be a void. This does not return a thing, it's just a void. And then in temperature.c here, what we want to do is temperature.now counter. Let's just a moment. You never do that. This doesn't do that. I know. No. So let's do temp sensor. And obviously, let's do this here. Just initialize the thing. I don't know. Okay, cool. So there's that. That's it. Okay. And then now I'm going to main, and I want to do this here. X. I want to do this at the end of this function. Okay, let's see. Redraw. Let's see how I do it in the BLE service. I have. How do I do it in the BLE service? BLE is weird because. So I need to find out how to. Can I do this all up here? we'll see. This is all gonna explode, isn't it? Do I need to have the temperature value now? Do I need to do this? I don't. I don't need to do this because I don't need to collect the... Do I need to? Does main need to do anything about this? No. Main doesn't need to do anything because what ends up happening is we start I'm looking at YouTube, see if anyone's talking. I don't need to. I don't need to collect this float here, and I probably don't need to deal with this float, do I? Do I need to do anything? I'm trying to think about it. I have a feeling the way I've arranged my sensor initialization might explode on me, but I think these two don't need to be dealt with. This float, see this one? That's what we do here. That's what we do here in our fetched, not even in our fetch temp. Here, float current. Okay. So in here we don't need to do this. And then here we also do this. Current message that value is equals to current temperature after doing that. So as well, we don't need to fetch the temperature because we are fetching it here. We are fetching it here. So in main.c we also don't need to do this. This is this now, this becomes our idle loop. Okay. So we've initialized the sensors. I have a feeling this is just gonna all explode in spectacular ways. Start our producer and consumer threads. So we need to start the thread we made for the sensor, and we need to start the thread that we made for the we need to start the thread that we made for the sensor and the one we made for the K-thread define, and then the one we made for the message threads. So how do we start threads? K-thread define thread creation. Yeah, I'm just looking for some sample code to see how to start K-thread define. K-thread define, spawning a thread. K-thread define, yeah. K-thread Okay, so let's go here. Let's start this one first, the reader. This one. Let's start this one. Let's first start this one. Okay. It's okay. Thread. So thread define. And in here we're going to take the thread, some thread ID that we will find just now, and then some stack size. This is temp queue size, temp queue size. And then here we're going to take an entry, which is temp sensor thread, and then in here we're gonna do null, just a null. And then we're gonna do a priority of, is it more important to read or to network? We'll do a priority of 5, and then here we will do a 0 and a 0. Wait, so let's just do this so we see what it takes. Okay, so K-thread define takes a name, a stack size, an entry point, pointer 1, 2, 3, and then a priority, and options, and a delay. So okay, cool. So let's put nothing there. So there's that. 0. Quite a few things are gonna come. It's fine. And then K-thread define. So temp thread. And then here's BLE temp thread ID, and then temp size queue. I wonder, do both of them have the same one? Both of them are going to be done by, yeah, temp queue, and then BLE. We need to expose those functions. PP. So in temperature.c, we need to get that. We need to expose u, y. In temperature.h, we need to expose u, v, and then in BLE service, we need to take them. Which one? BLE temp thread read, and we need to expose u as well. My BLE header is much neater than my temp header. And then there's that temp sensor thread, and then here there's going to be BLE temp, BLE temp, BLE service, BLE temp thread read. Temp thread read, and then also now, but this one is going to be a little less important, so we're going to give it a 6, and then also some 0, and then R0. Okay. BLE services H. Y. Okay. Let's go here, and then BLE temp thread read G. Y. I broke my code here. You know, in Elixir we have atoms. I just realized these are atoms. It's fine. We're gonna. Okay. That's nice. Act 2. Thank you, Act 3. Which means it's also wrong in the BLE service here. What else? What did I break here? Okay, thread define. Okay, let's also just go back here and see what is kthread define wanting. I feel like this might even work. But check out what has happened. So, okay, we don't also need this. We did do it. No? We did it. We've removed global state. We have no global state. There you go. We have removed global state. That's amazing. But I don't even know if it builds. Just build. Robust. Yeah, let's try that. If this does not explode, I'm pulling out a branch, I'm taking a break, and I'm coming back to make sure it works. I knew it. Temperature.c. What is wrong? Yeah, I knew that was way too much code to go at once, but it's fine. So let's just go to the top one. What is the first one? Invalid device identifier. Temperature.c where? Temperature.c what line? So we can remove that, and I want to see now this other error. Wow, this is so cool. So threads are defined as drivers, basically. I don't know why my mouse died, generally. Seeing if we have any other questions. 10:50. 10:40. We've not had views in the last hour. Okay, I'm gonna take a break there. I don't like taking a break when I have a code error. But I wanna take a break. on this. So okay, so far what have we done? We designed the pipeline. We did design a pipeline. This worked. Took longer than that. And then we implemented a sensor thread. Yes, we did. And then we implemented a BLE thread. No notifications. Yes, we did. And then we're now integrating and testing. This is gonna take long. Yeah. I probably need to define my sensor in some other fashion so that my my sensor can be initialized. There's something I'm doing something wrong here, which will actually make the whole thing build. My problem is here is how I'm initializing this sensor. If I can initialize the whole of this sensor in here with all the right well, I can also just go back to I can't go back to if I include all of the initialization in sensor.h, then it basically is run in main, isn't it? So I'm still doing it in main. No, I don't want to do that. What I want to go back to is the thing that was working before is I want to use a pointer. And if I can use a pointer if I can still keep this as the pointer it was before, if I can still keep this as the pointer it was before, I can use it. So static construct and then that, and then let's take this SV and let's just exit, and then here we'll just make that, and then in here what we can do, let's go back to the pointer. It was a pointer before, let's go back to it being a pointer now. It was a pointer before, but let's go back to it being a pointer now. So here, let's just do that and say, what do you want? Temp sensor equals that. But that's gonna break. That's gonna break now. If not temp sensor R, yeah. So this has already been defined as a pointer, and then this can be because this is already a pointer, we can just come back here and do that. And then in here, where we do this, because this is a pointer already, we can just do that. Pointers, baby! Amazing. Where did we get to? 12. Wow. So now what do we need here? So something is wrong with okay. Wow. Don't use that. Wait. What are you saying here? What are you saying? What are you saying? What are you saying? Use the function, not the I can do that. So you're saying use kthread create. It's a macro. It's a macro that's a problem. If I do that without the macro, it should work. So the macro is complaining because we are calling it in a function context here. Yeah, I want this done after. Create. So what is the let's go and look at this. Sample synchronization. Please just show me how to do this. Show me how to make my threads work. Perfect, perfect, perfect. Just show me where the fuck you are made. Oh shit, I shouldn't have said that. Close you. What if I put them in the global context? I don't know, I don't like that, but that seems to be like it might fix my issue. Yeah, we're going, our compilation is way deep, way deep. And this is gonna be hard. So it says multiple definitions of temp message queue. Multiple definitions of temp message queue. Temp message queue. I know where it's gonna be. It's gonna be here. Temp message queue. So the temp message queue here, and then BLE service temp message queue. No. temperature service, temp message queue, no. BLE service, temp message queue. I just use it. Temp message queue. Why is there multiple definitions? I know why. 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 I should. Is there one at the end? It's just an end if. It's just an end if. Cool. NRF dongle. In case it works, let's be ready to deploy with NRF util. In case it works. Template. Okay, we have a few things, and if undefined reference in BLE temp thread temp float. It's fine. BLE temp thread. Yeah. I see. I see what happens here. I see what's happening. Where's the reader one? Where's the and template? Yeah, I see now. So let's try float temp float, so that it's gonna be that, and then let's rebuild. If we get one less error, it will be fine. So let's see what happens. There's no way we don't get an error. Something must be wrong. Better, much better. So let's okay. So that's fine. That's that. That's that. That's that. I thought this would be before because we are. Let's just put all of this in. Yeah. No, that's too long. Let's put this, all of this in Google and see. I think this is a header issue. I think this is a header issue. Somehow I messed up my header. No. I know how you're going to BLE. You're going to BLE because I put in BLE stuff. I just want the multiple definition part to be on the multiple definition. Yeah, this is an issue. It's my order. Up.h should come fast. Where are we here? Okay. I really believe this is include up.h. Wait, BLE service. Let's see. I don't need that comment. Said last ever. That I'm looking at Discord and someone's saying Discord, someone's saying it's because my queue is actually defined in my header, which basically means I need to go here on here. I think it's struct temp message queue. Okay, message queue. We can also just put this in there. Can we do that? Hopefully I don't have to take a break with this not building, because I want to cut out the branch and put this on Discord and take a break. I don't even know. I don't even Okay. NRF U2. Yes, so we did find a way. did find a way. So I want to do the temp and light. Temp and light. So we built it. Let's package it. And then come TTY A TTY STM. Yeah. If this works, I'm gonna take a break. Yeah. Shit, isn't it? Yeah, that did flash. TTYSC, but that did flash. Why did it flash then? Shouldn't, because it's gonna be like, no, there's no. I don't understand it. USB. Yeah, I don't see an NRF guy in there. They wouldn't enumerate anyways because kill screen. Let's do that. Yes, let's try and make this guy flashable again. See if he shows up. Okay, LS USB. Yeah, shows up. DFU bootloader. Let's flash that. Anyways, let's flash that, and if it works, even though we don't have logs right now, LS USB. So that's it's no longer enumerating, means that's what's happening. Anyways, let's see. BLE, and I'm going to press connect. Connect. It's connecting. I hope I can see something. It did connect. Oh, it is connecting. It's connecting. Yeah, that probably means it failed. It failed and we're not getting logs. We might have to do West debug with this one. So that means something went catastrophically wrong. And it's only going wrong after the thing has been boot up. Okay, so that's broken completely. Git check out b pr add multi-threading. Okay. Git status git ls ref git status git add c commit -n initial stub at adding multi-threading. Okay, thank you so much everyone for hanging out and chilling out with me today as I explore multi-threading in Zephyr. We're using Zephyr and with networking and sensors in the loop. Let's see what I can do. I'll see if I can discover what the error is with this, and then I'll report back either in the evening or in the blog post that's going to follow. There's a branch up. If you see that branch merged, that means it's fixed, so you can check out what needs to happen. Thank you so much for coming. Thank you so much for chilling with me.